Okay, on to question 4. Your company officer assigns you the position of researching routers to install in your company spaces. You want to find the one that will provide the highest data rate and minimal bit error for streaming movies, music, and playing games. So calculate the data rate, or RB, of each of the router options below. Show work and label your units. So we're doing the same calculation for 3 different routers, just using a different equation based on the digital modulation scheme. So router option 1 uses 2 FSK digital modulation to transmit a signal, uses a bandwidth of 2.4 gigahertz and a frequency deviation, or delta F, of 500 megahertz. So we're going to use the bandwidth equation for frequency, or for FSK, which is going to be bandwidth is equal to 2 delta F plus 2 RB. Of course, here we know what the bandwidth is. We're trying to solve for RB, so we need to reconfigure this equation a little bit, and we end up with RB equals bandwidth minus 2 delta F over 2, right? So we just move that term over, subtract it, divide by 2, and that gives us our RB. We can plug and chug from here, so RB equals, our delta F is 500 megahertz, our bandwidth is 2.4 gigahertz, so we've got 2.4 GHz minus 2 times 500 megahertz, which 2 times that will give us a gigahertz, and then divide by 2, and we should end up with 700 megabits per second as our RB. Router 2, this option uses 8 PSK digital modulation to transmit a signal with maximum bandwidth 5 gigahertz, right? So 8 PSK, 5 gigahertz are the 2 things we need. We've got our bandwidth equation for PSK, etc., QAM, and all of those schemes. So we've got bandwidth is 2 RB over N, or RB equals bandwidth times N over 2. And so we do need to remember that N equals log base 2 of the 8 here, right? Or the number of bits, different values that we have. It's not bits, symbols is what we use here. So there are 8 different symbols, right? So log 2 of the symbols is N, which means N is log 2 of 8 for 8 PSK, which means it is 3. And so our RB is bandwidth 5 gigahertz times 3 symbols over 2, which gives us 7.5 gigahertz. Router 3 uses 8 QAM and maximum bandwidth of 8 gigahertz. So this is actually just the same calculation we just did, right? Because for QAM and PSK, we have the same RB equals bandwidth times N over 2. And so we're going to have the same values, and we end up with just this is also 7.5 gigahertz because it's the same basic thing. Next up, part B, we have draw examples of 8 PSK and 8 QAM constellation diagrams. So 8 PSK means we need to be anywhere on the same amplitude but 8 different phases. So we can start with just basically drawing circles around here, showing the different phases that we would be at, right? Different angles as we go around the circle here, but we're all on the same amplitude line. So you can choose whichever circle you want to be on here for your example, but we need to have all different phases, so all different angles, right? Because we'd have like this is 0 degrees, this is 90 degrees, so on and so forth, right? Is how we would label those. 8 QAM. Now we want to have different phases and different amplitudes, and we need to choose, maybe 4 of those. So the example given, I'm going to draw actually the opposite of what's in the exam there, just to give you another example, right? So we've got sort of one amplitude with 4 different things, and we've got them at different phases there, right? So this might be 0 degrees, 90 degrees again. And then in between, we're going to choose a different amplitude and a different phase for the middle points, right? So now we've got 2 different amplitudes and 4 different phases, and that gives us 8 different points And the idea here is that it should be easier to distinguish between these, because when we're at 45 degrees, we're at a different amplitude than we are at 0 and 90. So we go a full another 90 degrees at that amplitude before we have to recognize a different point. So then that should lead you to the answer for part C, which is at decision time, which of the three router options do you choose and why? Well, for the bandwidth, we want either 8 PSK or 8 QAM because it was 7.5 gigahertz versus the 700 megabits per second for the other one, right? So clearly we want the 8 PSK or 8 QAM. And so then why do we choose 8 QAM? Well, 8 QAM has less noise due to separation between symbols, right? As we just showed in the previous question part. So it's easier to distinguish what's being sent, and it has the same data rate as the PSK version. So we would choose 8 QAM. That's it for that question.